Hello everyone. In the previous class, we have learnt about what do we mean by chemical reactions and different examples for chemical reactions. And also we have understood what are the characteristics of chemical reaction by which we can say the chemical reaction has taken place. And also we have learned about what do we mean by the balanced chemical equation and why do we need to balance the chemical equation. In the today's session, particularly we are going to study how to balance the chemical equations. It is very important from the examination point of view. This is very important concept because not only for this chapter, for our upcoming chapters like metals and non-metals, acids and bases, we should have the knowledge regarding balancing the chemical equations. So let's learn now how to balance the chemical equations. And in the previous class, we have learned what do we mean by balanced chemical equation. When the number of atoms of each element on both side of the reactant and product side of the chemical equation are same in number, then the chemical equation is said to be balanced chemical equation. And why do we need to balance the chemical equation? Because in order to follow the law of conservation of mass, which says that mass can neither be created nor be destroyed in a chemical reaction. We cannot create any matter or we cannot destroy any existing matter. The total quantity of matter of elements present on reactant side should be equal to the total quantity of matter of the elements present on the product side. This is why we need to balance the chemical equation. For example, I will show you if this is a chemical reaction, hydrogen plus oxygen give rise to water, formation of water. What is the atomic mass of hydrogen? It is 1 AMU. Here it is in the molecular form. We have two hydrogen atom. So the molecular mass of this hydrogen will be 1U plus 1U is equal to 2U. Fine. What is the atomic mass of oxygen? It is 16. For O2, we will be having 16U plus 16U, that is 32U. Now see here, let us calculate the mass of the product here, that is water molecule. The atomic mass of hydrogen is 1U. Here there are two hydrogen atom and one oxygen atom. So it will be 2U plus 16U, which is the atomic mass of oxygen. Total it will be 18U, whereas on the reactant side it will be 34U, which is not equal to 18U. Here the mass of the reactants is not equal to the mass of the products. So we have to balance this equation. Suppose if I write this equation in the balanced form, that is H2 plus O2, 2H2O. This is the balanced equation so that the number of atoms of each element are equal on both reactant and product side. There are four hydrogen atoms here. There are four hydrogen atoms here. Two oxygen atoms here. Two oxygen atoms here. Now let us calculate the mass of the reactants and products. Here for hydrogen there are 4 in number. So we will be writing 4U for this. For oxygen we will be having here 16U plus 16U, that is 32U. On the product side we will be having 2 into 2U for hydrogen and 16U for oxygen, that is 18U. Now let us calculate the total mass of the reactants here. 4U plus 32U, that is 36U on reactant side. 18 2s are 36U on the product side. Now we have checked whether the mass of the reactant is equal to the mass of the product. It is balanced chemical equation. So that the total quantity of matter of the elements present on reactant side should be equal to the total quantity of matter of the elements present on product side. The mass of each element should be balanced on both reactant and product side. This is why we need to balance the chemical equation. Now we shall learn the steps for balancing the chemical equation. My dear students, let us learn different steps for balancing the chemical equations. This is the method which is prescribed in your NCERT textbook for balancing the chemical equation using table. This is hit and trial method. Once you keep on practicing different number of examples, it will be easier for you to solve it in a single step also. As we are new to the balancing of chemical equation, we have to learn it step by step. So let us take this equation as an example and start balancing this equation. Here the number of atoms of the elements are not same on both the RHS and LHS. The first step that we need to do is we have to write the number of atoms of each element present on reactant and product side. I will write here the elements present in this equation. That is iron, oxygen, hydrogen. We have to count the number of atoms in the reactant side. There is only one iron atom on the reactant side. Here on the product side there are 3 iron atoms. What about oxygen? There is only one oxygen atom here. On the product side, there are 4 oxygen atoms here. When it comes to hydrogen, there are 2 hydrogen atoms here. And on the product side also, there are 2 hydrogen atoms here. You can see here, the iron atoms and oxygen atoms are not balanced. But the number of hydrogen atoms are balanced here. And once we start balancing the chemical equation, we usually start with the compound having maximum number of atoms for our ease. And remember here, there is no specific rule that we have to start with this only. For our ease, we will start with balancing the compound having more number of atoms. Yes, now this is the compound having more number of atoms. You can see here the oxygen atoms are 4 in number on the product side, whereas here there is only one oxygen atom. So what we need to do? Here also we need to get 4 oxygen atoms. So how do we get 4 oxygen atom here on the LHS? By writing the coefficient in front of the formula. Remember that we are not allowed to change the chemical formula of any compound. We just need to write the coefficient in front of this formula. But we are not allowed to change the chemical formula. Yes, in order to make this also 4 oxygen atom also 4 in number on LHS side, I will multiply it with 4 so that it will be 4 on both the side. Let me write this equation one more time here. Fe plus H2O Fe3O4 plus H2. We have multiplied this with the coefficient 4. Now, not only the number of oxygen atoms are changed, but the hydrogen atoms are also affected. So, it will become 8. 4 to the 8 in number on reactant side. Now these hydrogen atoms will become unbalanced. We have to balance it. Now what we are left with? We are left with iron and hydrogen. Let us balance these elements in the next step. Our third step is we have to balance each element on reactant and product side one by one. So let me write the equation again. Fe plus H2O Fe3O4 plus H2. This is 4 here. In order to make the hydrogen atoms 8 in number on product side also, I will multiply this with the coefficient 4. Now here also there are 8 hydrogen atoms. Here also there are 8 hydrogen atoms. Now I will get 8 hydrogen atoms here on product side also. Now we are left with the iron atoms. We need to balance it. See here, there are 3 iron atoms here, only one iron atom here. What should we do? We have to write the coefficient 3 here so that Both the iron atom on RHS and LHS are balanced now. Finally, we have to check the correctness of the balanced chemical equation so that number of atoms of each element on are same on both sides of the equation. Yes, you can check here. There are 3 iron atoms on. Let me write this. Let me write the elements. Iron atoms, 3 in number. Here also there are 3 iron atoms. Hydrogen atoms, 8 here. 4 twos are 8 here. Then oxygen atoms, 4 here. Here also there are 4 oxygen atoms. So all these elements are balanced. Finally, our last step is to make the equation more informative, we have to write the factors like physical states of the reactants and products, heat changes, whether heat is absorbed or heat is released, that we have to mention, whether gas is being evolved and the precipitate is formed. We have to mention these factors in order to make the equation more informative. This is our balanced chemical equation. We have to mention the physical states of the reactants and products. We will write S for solid, L for liquid, G for gases, and AQ, aqueous solution for the substance which are dissolved in water. Here it is clear that iron is metal which is solid. Here iron reacts with water in the form of a steam. So I will write here G. It is not reacting with water directly, it is reacting with steam. So G for gas, Fe3O4 is solid, iron oxide is solid in state. So S for this, and we know that hydrogen is gas, we will write G for it. In this way, we have to mention the physical state symbol for reactants and products. Yes, these are some other examples for balanced chemical equations. Carbon monoxide, which is gas, reacts with hydrogen, which is also gas, at 340 atmospheric pressure to form methanol, which is in liquid state. We will write some of the factors like temperature, pressure, catalyst used above this arrow mark in order to make the equation more informative. Here there is one more balanced chemical equation which is called as photosynthesis equation, where the plants use carbon dioxide in the dissolved form and water in the presence of sunlight and chlorophyll to form glucose and oxygen. We have mentioned these factors here to make the equation more informative. In this way, we will write the balanced chemical equation including the physical state symbols for reactants and products, and wherever necessary we will mention some of the factors like temperature, gas evolved or precipitate formed. Whenever there is formation of precipitate, we can show it with the down arrow. This is formation of precipitate, that whenever there is insoluble substance formed. If we show upward arrow, then it is for gases. Whenever there is evolution of gases, we will show it with the upward arrow mark. When the reaction mixture is heated, we will show it with this triangle symbol. When the reaction mixture is heated. Once you solve many number of examples, it will be easier for you to solve it in a single step. My dear students, now let us balance some of the chemical equations here. You have learned how to balance the equation by using table method. Many a times it consumes a lot of time. So let us try to solve it in a single step here because time management is also very important. Okay, whenever you don't get how to start balancing the equation, follow this trick. First, balance metals. For example, sodium, potassium, copper, aluminium, zinc, etc. Then balance non-metals except hydrogen and oxygen. Example chlorine, phosphorus, sulfur, etc. Then balance oxygen. Lastly, balance hydrogen atoms. We can follow this order. Whenever you don't get where to start with, you have to follow this method. It will be easier for you to balance the chemical equation. Now let me balance the following chemical equations here in a single step. Here, sodium is already balanced, hydrogen is not balanced, but oxygen is balanced. Here there are 3 hydrogen atoms, here there are only 2 hydrogen atoms. Okay. Now I have to increase the number of hydrogen atoms on the reactant side. So I will write here 2. Now it has become 4 hydrogen atoms here, whereas only 3 hydrogen atoms here. But to make it 4, simply I will write 2 here. So that 2 plus 2 will be 4. 4 hydrogen atoms here, 4 hydrogen atoms here. Oxygen atoms are also 2 in number on both sides. No problem with oxygen element. Now I have to balance still sodium atom. Here there are 2 sodium atoms but only 1. So I will again write 2 here. So that all the elements are balanced. Okay. Then the next equation is Hg plus O2 give rise to HgO. There is only one mercury atom here, 2 oxygen atoms on the reactant side, only one oxygen atom on the product side. So straightforward I will write here 2. So that on both sides oxygen atoms have now balanced. But the mercury atoms again they are not balanced. So I will write here 2. Now all the elements are balanced. Let's see the next question here. CuNO3 twice give rise to CuO plus NO2 plus O2. Here, let's use this trick. As many products are formed here, whenever we get confused with where to start with which element to be balanced first, let us use the trick there. Okay. I will start with the metal. But actually these metal atoms are already balanced. The copper atom is only one here. Here also there is only one copper atom. So no need to balance it. Next comes the nitrogen element which is a non-metal. Yes, I will balance that one. Here there are 2 nitrogen atoms. Here there is only one nitrogen atom. So to make it 2, I will write here 2. But now the number of oxygen atom has also got changed. 2 2s are 4. 4 plus 2 6. 6 plus 1 7 here. Whereas here 3 2s are 6. We have to increase the number on reactant side. So I will write here 2. But you can see here the number of atoms of all these elements have got changed because of multiplying with this coefficient 2. Now the copper atoms have become 2 here, but there is only one copper atom here, and the nitrogen atoms 2 2s are 4 nitrogen atoms are there here, whereas only 2 nitrogen atoms are there here. Then oxygen atoms 3 2s are 6, 6 2s are 12, whereas here 7. So all these elements are unbalanced now. So I will start with the same trick. The order, that is metal, non-metal, oxygen and hydrogen again. I will start with the metal only. Here there are 2 metal atoms, that is copper. Here only one copper atom. So I will write here 2. Then comes the non-metal, which is nitrogen. Here the number of nitrogen atoms are 2. 2 here and 2 into 2, 4. Whereas here only 2. So I will make it 4 here. You can see the copper atoms are also balanced and nitrogen atoms are also balanced. Now let's check the number of atoms of each element on both reactant and product side. 2 copper atoms here, 2 copper atoms here. Nitrogen 2 twos are 4 nitrogen atoms here. 4 nitrogen atoms here. What about oxygen atoms? 2 plus 8. 4 twos are 8. 10. 10 plus 2, 12. Here 3 twos are 6. 6 twos are 12. On both the side, the number of oxygen atoms are 12 in number. So this equation is balanced now. Whenever you are having brackets like this, you should be very careful. This 2 number is related to nitrogen and oxygen atoms both. You should be careful while counting such number of atoms. Yes, let's see the next equation here. Fe2O3 plus Al, Fe plus Al2O3. Here, the metal atoms, that is iron and aluminium atoms, are not balanced, whereas the oxygen atoms are balanced here. So, here there are two aluminium atoms. I will write here 2. Then here there are two iron atoms. I will make here 2 iron atoms on product side also. Now, this equation is balanced. Yes, let's see the next equation. Fe2O3 plus H2SO4 give rise to Fe2SO4 thrice plus H2O. Here I can use one more trick here. On both sides of these compounds, the same group SO4 is present. I can use one more trick here. On both reactant and product side, the same polyatomic anion is present here. I can consider it as a whole one group. Even these atoms can be separately balanced as the same group is present on both sides. I will make it easier so that it will consume less time. So the SO4 group is present thrice here. Here only one time it is present. So I will write here 3. Why I have started with this only? Because already these iron atoms are balanced here. So to consider sulfur atom, I have considered this whole group, so that there is no need of balancing again for these two groups. What is left we have to see here. These iron atoms are balanced. Yes, this SO4 group is balanced on both the side. Yes, then see the hydrogen atoms here and oxygen atoms here. You can see that here one oxygen is present. Let's not consider these two because already the oxygen atom for these two compounds are already balanced. Let's not disturb these groups again. Here there is one oxygen atom. Here there are 3 oxygen atoms. So to make it 3, I will write here coefficient 3. Now the oxygen atoms are balanced. Let's see the hydrogen atom. Here there are 6 hydrogen atoms, that is 3 twos are 6. But here also there are 6 hydrogen atoms. 3 twos are 6. Now all the elements are balanced. See, I am telling you once again. It is hit and trial method. You have to keep trying which method goes easier for you. When can we get the balanced chemical equation? Very easily. You have to apply common sense also sometimes. Yes, then let's see the next question. The equation is C4H10 plus O2, CO2 plus H2O. Now straightforward I will go with carbon. There are 4 carbon atoms here. Let me write here 4. Now count the number of hydrogen and oxygen atoms here. Here 4 twos are 8 oxygen atoms plus 1, 9. Here only 2 oxygen atoms. Then what about hydrogen? There are 10 hydrogen atoms here. Here there are 2 hydrogen atoms here. How can I get 10 hydrogen atoms here? By writing 5. Now the number of oxygen atoms have again changed. 5 plus 4 twos are 8. That is 13 here. 13 oxygen atoms here. Whereas here 2. Here I will tell you one more trick. Fraction trick can be used here. To make 13 on this side can be somewhat complicated for you. As it is present in the elemental form, you can use the fraction trick here. Directly we can get the answer. Let me show you this separately. See here, we have got here 4, then 5. What is that fraction method that can be used for solving this it in a simple way? Here I need 13 oxygen atoms because overall we are having 13 oxygen atoms on the product side. So I should get 13 oxygen atoms here. How can I get this? By using simple mathematics. So let x be that coefficient so that I get 13 oxygen atoms here. We don't know what is that x coefficient. So 2 times this x must be equal to 13 oxygen atoms. Yes. What is that x? Let's find out. X will be 13 upon 2. So once you take 13 upon 2 here, I will get 13 oxygen atom on both the sides. Yes, I will write the equation one more time. But we cannot keep the equation with the coefficients in the form of fraction. We should never leave the equation where the coefficients are in the form of fraction. We should get rid of the fractions in a balanced chemical equation. How can I do this? Here there is only one denominator here. So by multiplying with that number, I will get rid of this fraction, this denominator. Yes, by multiplying the whole equation by 2. Now I will get 2C4H10 plus 13O2 give rise to 4 2s are 8 CO2 plus 5 2s are 10 H2O. Now let us count the number of atoms of each element, whether they are balanced. What is the number of carbon atoms? 2 4s are 8 here. Here also there are 8 carbon atoms. So this is balanced. What about hydrogen atoms? 2 tens are 20 hydrogen atoms here. Here 10 twos are 20 hydrogen atoms here. So these atoms are also balanced. Now comes the oxygen. 13 twos are 26. Here 8 twos are 16 plus 10. 26. Yes. Now all these elements are balanced. This is one fraction trick which you can use. Why I have multiplied it by 13 by 2? Because I need 13 oxygen atoms on this side. If I went on doing the trial and error method for this equation, I would consume lot of time. So I have used this trick here. You can also use this trick wherever necessary. Now, the next equation is NH3 plus Cl2 give rise to N2 plus NH4Cl. Now, I will show you one more method which is applicable to any complicated equation which needs to be balanced. You must know this method of balancing. Yes, I will write the equation separately here. This is called as ABCD method. Whenever you find that any equation is getting complicated and you are not getting the answer even after trying many times, then use this method. It will work for sure. Yes, but it takes some time. Don't go for it directly. But whenever it seems for you that equation is very complicated, I am not getting the answer, then surely you can use this method. Yes, what we have to do is we have to write the coefficients A, B, C, D for all these compounds. Because we don't know that coefficients. We have to find that coefficients so that the equation is balanced. After this, what the next step we have to do is we have to make the equation for each element. What are the elements present? Present nitrogen, hydrogen, chlorine. Let me make the equation for each element. See here, we know that the number of atoms of each element should be equal on both RHS and LHS. So, I will write the equation according to that A times that of this nitrogen should be equal to, here the nitrogen is present on in both of these compounds. 2 times that of C, because 2 nitrogens are there here, 2 times that of C plus D times the number of nitrogen atoms on LHS, that is A, should be equal to 2 times of C plus D. The total number of nitrogens present in both of these products must be equal to the nitrogen atoms present on the reactant side. Again, I will construct one more equation for hydrogen. 3 times that of A should be equal to 4 times that of D. Yes, the number of hydrogen atoms here should be 4D. We don't know what is that D, that we have to find out. What about chlorine? 2 times that of B should be equal to D. Why we have equated this? Because we know that the number of atoms of each element should be equal on RHS and LHS. So we have made these equations. Then the next step is to find out which coefficient is repeated most. We can see here D is repeated most. We have to set that coefficient as D, as 1. We can take any coefficient as equal to 1. But to easily solve the equation, we will take that coefficient which is repeated most. Yes, then if you put D is equal to 1 here, what will be the equations for chlorine and hydrogen here? Let's see. 3A is equal to 4 for this equation. So that A is equal to 4 by 3. Then let's see for chlorine. Then for this equation we get 2B is equal to 1. Therefore, B is equal to 1 by 2. We have got DAB. Let's find the C here from this equation. A is equal to 4 by 3 as we know here, which is equal to 2C plus D. D we have taken 1. Now 2C is equal to 4 by 3 minus 1. 2C is equal to 1 by 3. So that C is equal to 1 by 6. Now substitute all these coefficients in the equation. I will write the equation here. What is A here? It is 4 by 3. What is B here? 1 by 2. What is C? 1 by 6. What is D? 1. So this is balanced. But remember, I am telling you once more that we should never leave the equation which consists of fractions. We should get rid of the fraction in the final equation. Otherwise, you are not going to get the full marks here. How to get rid of the denominators here? Simply by multiplying with the LCM of these numbers. For 3, 2, 6, you know the simple mathematics, the LCM will be 6. So, I will multiply this entire equation by 6. Now, see, 3 ones are 3 twos are. So, this will be 8NH3 plus 2 ones are 2 threes are. 3Cl2 give rise to 6 ones are 6 ones are. So, N2 plus 6NH4Cl. This is the final equation. You can count the number of atoms of each element. 8 nitrogen atoms here. 2 plus 6. 8 nitrogen atoms here. 3 twos are 6 chlorine atoms here. 6 chlorine atoms here. 8 threes are 24 hydrogen atoms here. 6 fours are 24 hydrogen atoms here. So, this equation is balanced. Even though it seems like this is a lengthy method, where you should apply this method only when the equation seems so much complicated for you and you are trying it many times and you are not getting the answer, you can surely try this method. So this is how we will balance the chemical equations following some of these tricks here. Yes, what you should do is you have to count the number of atoms of each element on both sides and start balancing the equation. And you can use this trick. You have to follow this order for balancing metals, non-metals, oxygen and at last hydrogen. And wherever necessary, when it is taking more time, you can use the fraction method also like this. And when the equation seems complicated for you, you can also use the ABCD method where you have to form the equation for each element present and you should make the equations for them. Then taking any one of the coefficient as equal to 1 which is repeated most, you will get the coefficient ABCD, and in the final answer if there are any fractions present you should get rid of those fractions. This is how we will balance the chemical equations. Then what are the points to be noted while balancing the chemical equation? Let's see here. We should never change the chemical formula of the compounds. You have to keep it in the mind. Then atoms of all the elements should be balanced. You should never leave any element which is unbalanced. You have to check for it in the last step. Then there should not be common multiplier in the equation. What do we mean by this? See this equation. This equation is balanced actually. But we cannot leave the equation in this form because it is having the common multiplier, that is 2. 2 ones are, 2 threes are, 2 twos are. The correct form of equation which can be represented is in this form, N2 plus 3H2, 2NH3. You should never write the balanced chemical equation which is having common multiplier. It should be in this form which will be not having any common multiplier. These are some of the points to be noted while balancing chemical equation. Let us solve few more questions on this. When the description of the reaction is given, we have to write the balanced chemical equation for them. See here, these are the examples where the description of the reaction is given. We have to write the balanced equation for this. Yes, let us read the question. Calcium metal reacts with nitric acid solution to form calcium nitrate and hydrogen gas. Yes, symbol for calcium Ca. It is in solid form. It reacts with nitric acid solution, that is HNO3. Those substances which are dissolved in water, we represent it by AQ, that is aqueous. To form calcium nitrate, CaNO3 twice. We know how to write the chemical formula of the compounds which we have learnt in the class 9. Yes, this is soluble, so we have to write here aqueous for this, and hydrogen gas is formed. We have to represent it with G. We have written the state symbols here, but still this need to be balanced. Yes, the calcium atoms are balanced. The nitrogen atoms are not balanced. Oxygen atoms are also not balanced. Again, you can use one trick here. The NO3 groups are present on both sides. Yes, here there are two NO3 groups. Here there is only one NO3 group. I can balance this whole group. Yes, by writing here 2. Now here also there are two NO3 groups. Here also there are NO3 groups. And now you can check for hydrogen. Here there are two hydrogen atoms. Here also there are two hydrogen atoms. And as a whole, this group is balanced. NO3. NO3. It is also 2 times here. This is also 2 times here. And we know calcium is already balanced. So this is the balanced chemical equation. Now, sodium hydroxide solution in water reacts with hydrochloric acid solution in water to form sodium chloride solution in water. Sodium hydroxide is NaOH. It is solution in water. So, I will write here AQ. It reacts with hydrochloric acid solution which is also in water, that is AQ, to form sodium chloride, that is NaCl. It is a salt soluble in water. So I will write here AQ for it, plus water is formed which is in liquid state. You can check this. Sodium atoms are balanced. Chlorine atoms are also balanced. Number of hydrogen atom 2 here, 2 here. These are also balanced. Then oxygen atom, only one oxygen atom here, one oxygen atom here. So this equation is balanced. This is how you should be able to write the chemical equation even when the description of the reaction is given. For this, what you have to do is you have to remember how to write the chemical formula of the compound. Many a times students will get confused. For example, for this you can see here. I have written CaNO3 twice. Many students will write CaNO3, calcium nitrate. This is not true. For this, what we have to do? We have to apply the method. How to write the chemical formula. I will show you once more. CaNO3. We have to write the cation and anion for this. What is the charge for calcium? It is +2. For nitrate anion, it is -1. So crisscross these charges, we will get the formula of the compound. Yes, whenever you get confused, what is the chemical formula of the compound given? You can apply this method. Yes, this is all about the balancing of chemical equations.